Hello there, algebra students. Yeah, you can see this, and hopefully you weren't too confused when you heard the directions here. For the moment, I would like to skip sections 5 and 6 and go through those with you in person. I would like to jump ahead to section 7. So if you could pull that up on your content library and then drag that over into your class notes. We're going to start here. We're going to talk about tables and graphs. Again, our goal here is to take data that we've been given and organize it somehow. Okay. So, yeah, the first one here may take you by surprise. Data are specific pieces of information collected from an interesting group. I don't want to get too much into the terms that I use in my AP statistics class. Um, I don't think that's necessary at this point in time, but I do think you should know data is not singular, data is actually plural. Okay? Data are, not data is. Data are specific pieces of information collected from an interesting group. Now we can arrange that data into, yay, a nice little chart here. Well, actually, that's not a chart, that's a table. You know, just listing all of the specific information that we've collected. It's really hard to tell if there's anything interesting going on if all we look at is a table. So one way we can then arrange this that maybe helps tell the story about something interesting about the data is making a bar graph. So a bar graph is an arrangement of rectangles where the size of the rectangles represent the data. Just looking at a table, it's hard to tell trends. It's hard to tell what's exactly going on. You can't summarize it very well just looking at the individual pieces of data. So we're going to draw a couple of different examples of bar graphs. And then a line graph is, again, a representation of data using points and segments. So here I am getting a little bit specific with the distinction there in geometry rather than just one line, we're going to draw segments. Again, it's an attempt to organize it in a way that we can see a trend. Okay, so let's take a closer look here. Example number one, this table gives media consumer spending. Our unit of measurement here is the average dollar per person per year in the United States. Now, again, please forgive me, this is going back a ways. But the data is still valid. Um, we can still see what's going on here. Make a table showing the total media spending for newspapers, magazines, and consumer books. Okay, so if they're saying here specifically newspapers, magazines, and books, newspaper, magazine, book, so they've given us too much data. They don't want us to pay attention to that at all. So to make this table, we're going to add those three amounts together and create a new table. Because again, we're trying to answer the question, in what year did Americans spend the most? So now it's going to be a matter of, we'll take those values and add them. So going all the way back to 1996, this is $165.03. Now, we had a problem earlier when we were trying to estimate, answer the question, how much is this going to cost if we only have this much money? And we rounded things off so we could estimate. In this case, since we have the specific data, we're not going to round these. We're just going to do the simple arithmetic. So for 1997, that adds up to $165.40. Okay, very, very similar to 1996. 1998, it's $169.49. For 1999, $174.38. And then in the year 2000, $170.46. So once we've done the addition, so we've got all that basic arithmetic, nothing fancy. Don't need any kind of special function on a calculator here. Here are the totals spent on those categories, and hopefully we can say that it was 1999 was the year in which Americans spent the most on those consumer media categories. So example number 2 here, what they've done is that same set of data up above, where we ignored cable and satellite TV. Here, this bar graph shows the amount Americans spent for cable and satellite TV between 1996 and the year 2000. It appears that Americans spent twice as much in 2000 as compared with 1996. So again, we take a look at that height of this in 1996 and take a look at the height of this in the year 2000, it looks like this rectangle here at the end is twice as tall as that one in the beginning. However, this graph is misleading. Characteristics of a good bar graph are, in this case, we have these 5 different categories there. You'll notice that there are spaces between them That's actually a good thing. Okay. The fact that across the bottom, not only is each rectangle labeled, but there's a title there telling you what those numbers represent. It's not thousands of dollars or thousands of minutes, it's the year. That's a good thing. The scale on the vertical part of it there, it's clearly labeled. Ooh, what's that? Okay, that little jagged, it's like from a EKG or a seismograph there. This is where the problem comes in. The fact that we have the numbers labeled, that's good. It's given a title here. They're showing amount in dollars per person. That's a good thing. Where this can be misleading is this. Okay. If we go back up to the table up here and take a closer look, if I can undo my scribbling, it goes from almost $140 to just short of $200. All of those values there are in the hundreds of dollar range. Okay. Now, if you look at everything else below it there, it's going out to the tens. Catalyte, sorry, satellite and cable is in the hundreds place for the first digit there. And since the lowest value is right around 140, to save space sometimes, they will make this little break in the graph. And as long as they're marking it, that's fine. We as consumers have to understand what that means. Because to say this interval here represents 100 and then this interval here represents 20, that's an inconsistent scale. That's deceptive. It's misleading. It might be intentional. Okay? So we have to be careful and we have to be smart consumers about things. The bar graph could be misleading because the break in the amount side of the graph, anytime that there's this break in the data, so that we can zoom in a little bit and take a closer look at the differences between them, we should never compare proportions in this case. Well, I'm sorry, let me clarify that. Another good thing here is that for each of these rectangles, they're the exact same width. And that's what we should have with the bar graph. So interpreting the meaning of this data, all we're looking for then is the height of those rectangles. The issue here is when they say twice. Yes, that graph for 2000 is twice as tall as the rectangle that they drew for 1996. But if there's a break in this, we should never compare proportions based on the height. We only compare differences based on their heights. Okay? So again, from this graph, we should be able to interpret that this is just a little bit less than $140 per person. And from this graph here, it's somewhere around, say, $190 per person. Okay? We can say that spending on cable and satellite television increased by approximately $50. But if you look at those actual numbers that are represented from the height, saying twice as much, no, that's clearly not true. 190 is not twice as much as 140. All right. There's going to be a pause in the, the video here. What they're asking you to do is draw a new bar graph for example number 2 that would not be misleading. So again, you need to go back up to this row in the table and see if you can come up with a bar graph that's better than this one. Now again, I've already pointed out several different aspects of what a good bar graph is. Let's see how many of those remember. If not, of course, you can go back and rewind. I'm going to let you have 3 minutes. Ready to go. Once you've finished your graph, and you don't want to wait for the video to keep playing, you can fast forward up to the 20-minute mark. If you can see the timer down at the bottom there. Okay, let's take a look at what you hopefully did. One of the first things that I would look at is the fact that, yes, year is labeled, but of these individual rectangles here, we need to specify that this is 96, 97, 98, 99, and the year 2000. Okay, so make sure that you have those labeled. Going up the vertical side there, again, it's got the title, dollars per person, the amount spent. But again, we need to put specific numbers in here showing what our scale is. Now, if we go back and take a look at this one, they zoomed in on here and it went from 100 to 200 and we had that break. I would say my best bet is probably to say that this is 50, 100, 150, and 200. You may have a slightly different scale, but hopefully you didn't put a break in there like they did for theirs. So then it's a matter of, all right, we need to represent the actual data itself. So $138.96. That's not perfectly understood by looking at this graph here when it was zoomed in to a much smaller range. It's going to be impossible to put that in here exactly. But again, what I would say is, are we going to be able to do this? No, because it's, I can get that, and then I can adjust this to, again, if this is 100 and this is 150, 138 might be that much. Then for the next year, it was 153.11. And again, I'm going to mess around with the position of it here. 153.11. I'm just going to put that just a little bit above the 150. The next one, 165.56. Oh, come on. And again, with my scale here, I'm not so much worried about being able to completely nail the 165.56. I'm wanting for my graph here to show that it was in fact an increase. The next year, 179.89, so almost 180. Now again, here's 200, so that'd be 175 is halfway between 150 and 200. So I want to go a little bit past one's halfway there, 175 up to about 180. And then 192.82, just under the 200. So again, I'm trying to get them so that they're the same width and fairly close to the 200. Okay. Now we're not going to make that same mistake as before, saying that, oh, in 96, hopefully this rectangle here doesn't look like it's half the height of the one for 2000. All right, with example number 3 then, we have data here from 1994 to 2001, the average amount spent per student in the United States in public elementary and secondary schools. Here's a lovely table. Now we're supposed to draw a line graph of the data. Okay, so again, we're starting with the title down here that it's years, and each of these vertical lines is going to represent a different year. Our data here starts in 1994, it ends in 2001, so we're not going to make any marks on this or on this because those aren't labeled. We don't have data. We're not going to touch those. Okay. Over here, we have amount in thousands of dollars. Okay. They're trying to get you to acknowledge that fact that it's not dollars, it's thousands. Each unit on the horizontal axis represents 1 year, starting with 1994. So now it's going to be a matter of, all right, can we take these numbers and do our best to estimate? Okay. So in 1994, it's just under $6,000. So I'm going to put a dot there. For 95, it's 6,208. Now again, this little space here is $1,000. So 6,200 isn't up here. It's barely above the 6. 6,443. That's not even halfway. 67, maybe about there. And then for 1998, it was 7,100, 7,500, 7,800, 8,194. Do your best to estimate those. I'm not going to say, oh, that dot's in the wrong place. It should be up 1 millimeter. No. Okay. As long as you've got it in the right range of values here, I'm hopefully not going to be that picky. And then, yeah, I'm going to forget about you. Play connect the dots. It looks like we're increasing the spending from year to year, but it's not a consistent rate. So I think depending upon what kind of data you are given, to put one line that goes through all 8 of these points is impossible. Okay? So all I'm expecting you to do then is plot those points as best you can, estimate them. It is possible to get them wrong. If that last one is supposed to be 8,194 and you put a dot right there, yeah, I'm going to mark that wrong. That's 6,000. That's not 8,194. But if you have it here rather than there, I am not going to worry about that at all. Okay? So again, just dot to dot to dot to dot all the way across there. Now again, with this line graph, we can see that, yeah, the trend is that it's increasing, but that line is not very steep. If we try to put one line that gets close to those points, I am going to go there. In statistics, we would call that the line of best fit. It's not going to hit all of the points. That's going to be impossible. But a line that comes as close as possible to each of those points, all right, it'd have a positive slope. It's going up, but it's not very steep. Again, trying to give us a visual summary of what the data tells us. Increasing in public elementary, I'm sorry, the spending in public and elementary secondary schools is increasing, but it's not increasing very fast. All right, hopefully you got the hang of this here. Bar graphs, again, several things. There should be gaps. Each of those bars representing the different categories, in this case, the different years, should have a space between them so that the only difference from one rectangle to any of the others is their height. Make sure you label what variable is on the bottom and what each part, what each rectangle represents. Make sure that you've got a title on the vertical side there, and you've got that scale evenly, consistently spaced. Okay, so go over to Delta Math, take a look at what they've got there, do your best to answer those, and that'll be due next class.